domain. We change the domain, but in the same topics. Thank you.
Exactly. I may hold that, it's okay. So, as Paula introduced me, I will go directly in the presentation and give a small introduction about vocabularies and metadata. Talk about vocabularies and specifically about the National Environmental Research Council vocabularies that we host in BODC and the features of those vocabularies. What kind of applications can be used and the technologies we use to implement them. And lastly, I will talk about vocabulary governance. So metadata is structured information that describes, explains, locates, or otherwise makes it easier to retrieve, use, or manage an information resource. We often call metadata as data about the data or information about information according to the National Information Standards Organization. So for an image, what kind of metadata we could have? So we could so we could have as a metadata of the image, we could have the name of the image, the title, the type of the image, if it is like JPG or anything of TIFF, PNG, or whatever else. You can gather a lot of metadata about just a picture and use free text to describe. But it's better to, wherever you can, to use drop-down lists. So type could be described through a drop-down list as JPEG, TIFF, PNG, or GIF. And we would do that mostly to help people collect information in a similar way and to assist content authors in consistently tagging their content. And we mostly add metadata in order to find them. So we will enable users to find the information they need by translating their language into the language that the information was stored with. So if we formalize these drop-down lists, we can result in controlled vocabularies that in information science are carefully selected lists of words and phrases which are used to tag units of information so that they may be more easily retrieved by a search. They are important because they can capture expertise in agreed and well-defined descriptions. They enable population of a given field in a metadata model with standardized and unambiguous terms. They enable records to be interpreted by computers, and they promote consistency and interoperability. So the concept of controlled vocabularies is an essential part of BODC's data infrastructure. And of course, it has evolved through the years because it has started as loosely managed basic code tables, and it has now resulted to be an integrated semantic resource that has formal content governance. It is based in internationally agreed knowledge management standards and semantic web technologies. So our vocabularies are described in RDF, which is the Resource Description Framework. They are based on SCOS ontology, the Simple Knowledge Organization System ontology. And for every concept and every term and every vocabulary, there is a unique URI assigned. So if you select this URI, this will resolve to a document that is fully standards compliant. It is described in RDF XML, and it conforms to linked data standards. And that has allowed the vocabularies be adapted worldwide, as depicted in this picture. So you can see how NVS2 connects to the world. With yellow, you can see how NVS connects with other RDF vocabulary resources, but it also connects with non-RDF vocabulary resources like the marine species and RV infobase. We also connect with non-RDF datasets with Purple, like Sea DataNet and the Ocean Biogeographic Information System, and also with RDF datasets like BBC and the Rolling Deck to repository in US. So how would a user select a vocabulary to start tagging his metadata? There is a document on the web about the best practices for publishing linked data that has created a checklist and says that it is best practice to use or extend an existing vocabulary before creating one. Because as humans, we always want to have our final signature in everything we do, but it's good to reuse, and that's why all these people publish everything, open source programs and controlled vocabularies. So, but before selecting a vocabulary, it is important to ensure that the vocabularies that you are going to use are published by a trusted group, that these vocabularies have permanent URIs, and that they confirm, and you should confirm the versioning policy of these vocabularies. There is also an extended checklist for vocabularies that says that the vocabularies must be documented, meaning that you need to know who is the owner of the vocabulary, who is the publisher of the vocabulary, who is the manager, and what is the subject of that vocabulary. But it should also be self-descriptive, meaning that the terms of this vocabulary should have definitions and labels and titles. It's good, it's important to have the vocabularies described in more than one language. And before using something, it's important to see if other data sets use it too, so that it's more trusted. And another important thing is to know that the organization or the authority that publishes this vocabulary has confirmed that they will be maintained for a long time period or without any stop. Yes, we said about the trusted group and the URLs and the versioning policy. So in BODC, we host the NERC vocabulary server, which gives access to lists of controlled terms that relate to the oceanographic and the wider community, oceanographic domain and the wider community. It is based in SCOS, which has the concept as its fundamental entity, which is an atomic piece of knowledge. And we use several attributes to describe our concepts. I'll show this example directly. So this shows that we have a unique URI for each one of the concepts that we describe. This concept is comes from marine species. It has an identifier, which is an alphanumeric string. It should be unique, devoid of semantics. It's mostly used by software. And it should also have a preferred label, which is the human-readable description of the concept. We do use alternative labels. That one doesn't have, and we use alternative labels mostly for abbreviations of the concepts or for software that can't handle spaces. We mostly have a definition which is an unambiguous, a clear and unambiguous statement of the semantics of the concept. There is also a version info. So this is how many times the attributes of the concept have been changed since it was first published. And we also have a status here. We never delete there is a status that says that this concept is either deprecated or accepted. So here that says deprecated false means that this term is accepted. We'll talk about deprecation later on. And finally, there is a date, which is the last publication date of this concept. So apart from concepts, we also publish concept aggregations. And there are two types of concept aggregations that we publish. One has to do with concept collections, which are aggregations of the concepts that may be used to populate a specified field in a data or metadata model. And the other one is the concept scheme in SCOS, which is a concept soup, bringing concepts from different collections, different vocabularies together, and interlinking them with semantic relationships like broader, narrower, same, and related. In order to do that, we also have to select some top concepts as entry points to these schemes. And I'll show you an example. So this is a concept collection. I'll try to go to, I hope is it Chrome that will open? Let's try. I don't mind for that one, but I'll check the next one. I think it's there. So this is P08. All our, I'll tell about URIs. So this is a vocabulary, a controlled vocabulary that has several concepts listed underneath. Its description says that it lists the parameter disciplines, and it is used in a discovery interface. So we use this vocabulary to help the interface discover data. So this lists all the concepts. And if you go, how do I right click? Can I? Maybe this. No. It's okay. I won't right click. So it shows all the concepts underneath this collection. What we said about vocabularies that are documented is shown here, so you can see who is the creator. So you can see who is the creator, who is the manager, and who is the owner. It doesn't have to be the same organization. And the date of publication, and of course the subject. And this is the scheme, so the Thesaurus. This one is about Netmar and the Sea Area Gazetteer. It has two top concepts, and each one of them goes to several vocabularies. I'll try to use I want to find Chrome. Maybe like that. Okay. So this is a scheme that was used by Netmar project, again for the discovery interface. So what they wanted to do is to have instruments, and when you click on the instruments, so instrument comes from L19 vocabulary, and it lists P05 vocabularies, which are categorizations of sensors. And if you click in each one of them, it will take, so these are categorization of devices, and if you click in each one of them, it will take you to the phenomenon that it observes. So it is instruments, their categorizations, and the phenomena that they observe, all in one scheme. Okay. So, as we said, there are patterns on the URIs to connect to NERC vocabulary server. So if you want to connect to a list, this is the same. Always you have to change the three alphanumeric string, the 3-digit alphanumeric string. And if you want to connect to a certain concept, you have to use this URI. Like that. That gives you, takes you to units vocabulary. So I'll skip that and just say that because we do have mappings to the world, when data sets are annotated with controlled vocabularies, they interlink their data with a rich and fast-growing network of other data sources. So that's how they become more discoverable, interoperable, and eventually machine-readable. So right now, we do have 206 vocabularies, consisting of 161,000 terms, and they're growing. So another feature of NVS is the mappings, which can be internal and external. So we map either to NVS2 concepts or to external links. We use these 4 predicates, and these are examples of mappings. This is cryosphere as a discipline, and these are some mappings like same as, broader, narrower, related, and that one is going out of NVS. We do have a versioning policy in NVS2. So its concept, as we saw, has its own version. If anything is changed on one of the attributes of the concept, we change version, but the concept is stored as it was previously, as it was before. Changes can only be applied for broadening the meaning, but not to narrow the meaning. And any change on the concept will change the version of the collection too. And that's about provide versioning policy. In NVS2, we never delete, but only deprecate. And if the concept that is deprecated is replaced by something else, it will be stated here. So this concept is deprecated and is replaced by that concept, so that software that uses that don't go to broken links. This one is about multilingualism. So we don't really have multilingual concepts, but that was a proof of concept, giving definitions with different labels and scores. The collection is A01 and shows that. And finally, another feature is that a few of BODC vocabularies are built from semantic models. So they are composed by other BODC vocabularies. So this is an example, which is the concentration of lipids per unit wet weight of biota, of Mytilus galloprovincialis, and all the other next to that. So this consists of 5 different vocabularies. The first one is the measurement property. It's a vocabulary on its own, and the value is concentration. The second one is the measurement statistical qualifier. For that one, it is not specified, so it is not shown up there on the description. The third one is the chemical substance, which is lipids, and it's that one. The fourth one is the measurement matrix relationship. So this is the per unit wet weight of, and it is written here. Matrix is the next one, which is biota. And the last one is the biological entity, which is Mytilus galloprovincialis, and all of them together synthesize the whole term. So how do we use NVS? So one big thing why these controlled vocabularies have been built is to be able to create metadata records and assist the content authors in consistently tagging their content. In CDataNet, which is the pan-European infrastructure for marine and oceanographic data management, they have created tools that manipulate and take and import the vocabularies. There is a tool called Mikado that what it does is that it creates XML metadata entries, and you can also edit your XML metadata entries. When you start using it, there is an option to update your vocabulary lists. So it connects with a SOAP service to our vocabulary server, updates the lists, and after that you can use it offline. And as soon as the codes are there, then you can create your metadata based on codes that come directly from the vocabulary server. Another important use is to search existing metadata records. So since you annotated your data and metadata with vocabularies, you can now search nicely. We do use the vocabularies in BODC's discovery interface. So this is our discovery interface to get data. So this is P08. It lists the CDataNet disciplines. So we'll come here. And these are the disciplines coming from this vocabulary. So it is atmosphere and biological oceanography. If I select atmosphere and then select narrow, I'll see two of the vocabularies. So in atmosphere, the two vocabularies that you see come from P03 vocabulary. So if I select that one, which is meteorology, and I select the same one here, and click narrow, I see, oops. So I see the meteorology and all the P02 concepts that are narrower. So what did I do? No. So let's go again to the parameter. So if I select air pressure and narrow, so I think air pressure should be that one. And then it will take me to P01, which is the parameter vocabulary. So you'll then go to specialized parameters, select one, and get the data that include this parameter inside. So this is one of the uses of no? Is it this one? Okay. The same is used by CDataNet and Artoir. And there is also other software that CDataNet has developed for metadata tagging and data tagging. So how can you access NVS? The first web service, yes, is through a RESTful interface, or through a SOAP web service, or through a Sparkle endpoint. The RESTful interface can be accessed through URIs, and that's a URI that you can get all the collections. The SOAP web service can be accessed through methods, and when you implement the web service with the WSTL file that is there, you use the get collection method to get exactly the same collections as the RESTful interface. And the Sparkle endpoint uses the queries. So you can write Sparkle queries, and this query just fetches the same collection as the
Pronto?
thing to other interfaces.
Sì, può darsi che facciamo un quarto d'ora di tardi, io ho un convegno, però al massimo a tre quarti che mi spiace.
Paolo, hai il microfono acceso.
Mm. No, perché io sto seguendo un workshop in Italia modo, e quindi devo almeno aspettare che
Paolo?
finisce, devo sentire come sgancio.
Paolo?
D'accordo?
Paolo?
Sì, 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 perfetto. Ok, niente, figurati, ciao.
Paolo, il microfono acceso.
Scusate.
So, and these are Google Analytics on how our interfaces are used by the world. Italy is a very one of the leading users of the RESTful interface. The soap hits probably because it's Maris from CDataNet use that service a lot. They are the leading users. And sparkling points, Barbara, are used by Austria a lot. So the tools that we have, so we have created three kinds of tools to interact with the vocabulary server. The first one is the vocabulary editor, so that people that want to govern their own vocabularies and host them in and give them to BODC to host them can create their own terms and submit them. I'll try to give a okay, so I'll change that. Okay. So you have to log in. You have to create an account. You have to have a consent with BODC that you have your own vocabularies, and then you can work with them. I'll try one more time. So normally, if you have your own vocabularies, you would see one of the vocabularies underneath that list. You can either edit a single list or create mappings to your vocabularies, to your concepts. So if I select that list, and wait, I can see the terms, and I can edit them and submit. I can deprecate them. I can change something, so the version will also change. And I can also use bulk update to give a list of concepts that I want to add in my collection. So this is about the editor. but we also have a search interface. So here you can search for vocabularies or search inside vocabularies. If you're totally new, you probably want to search for vocabularies. So if I want to search for salinity, I will get all the vocabularies that have salinity inside them, ranked with most hits of salinity inside each one of the vocabularies. P01, which is the parameter usage vocabulary, could be a good candidate. So now you're in the vocabulary, and you're searching in the vocabulary, checking the terms. We do have two types of searches. One is the simple search, but if you become a good user and an advanced user, you can use advanced options. Search in specific labels. You can also have filters to include or exclude terms. You can have case sensitivity or exact matches. When you're searching like pH, and pH can be found wherever, but you can use like exact match to find your pH. So this is a tool for users to start finding their concepts. And we also have a brand new one, which is the vocabulary builder, which uses the semantic models. So this one shows exactly what we said about the wheels of the vocabularies. So P01, the chemical substances in P01 consists of 1, 2, 3, 4, 5 wheels. I call them wheels because they look like the fruit machine wheels when you combine them. So you can, at first, the tool is used as a search tool to search for a term combination. And if you don't find the term and you want it, you can create it and submit it to our vocabulary management team. So in the measurement property, you can search for, let's say, concentration. You will see it up there. This is the measurement statistical qualifier. If I select not specified, I didn't. You will see that here it shows how many matches of these terms we have. We also search for a chemical substance. So I can search for lipids. So this one is the lipids. Now my matches are much less. And then I can also find the measurement matrix relationship. So per unit dry weight off. I have 8 matches now. And then go to matrix, select biota. And if I select biota, then another wheel comes up, which is the biological entity. So here I can search for methyllus. And have methyllus, let's put one of them. So as you can see now, selecting methyllus edulis, I have no close matches. So there is no such a term in the vocabulary. And if I want to create that, I can go in and create it. And this is submitted to the vocabulary management team that will review the submissions and go on, contact the person and go on and create the new term. So You can also create terms in each one of the wheels. So you can come directly here. If you see that you don't find the term that you want, you can directly come to the create new and create a new term. This will be on the pending list and you can directly use it. So I'm going back to the presentation and oops. The technologies that we use, we don't use out-of-the-box software. Apart from Jenna Fuzeki as our Sparkle server, we have an Oracle database as a backend. We use Java as a programming language and Jenna TDB for our RDF storage and Fuzeki for the Sparkle server. Another important aspect, and the final one, I won't talk anymore, is the vocabulary governance. So we do have types of governance. One of them is the content governance, which is very important because if you do have it and you do it correctly, you get trusted. You get trust from other people and other people want to connect to the vocabularies that you publish. It determines the concepts to be included in the controlled vocabularies and their labels and definitions. And the other one is the technical governance, which is how this data will be stored, versioned, and served as controlled vocabularies. So in the history of the oceanographic data management, there were many bad examples, like decisions made by individuals, like students could have a button and submit terms that went into the controlled vocabularies, or decisions were taken with no thought or inadequate thought, or someone governing the vocabularies would say yes to any concept. But there could be different models that you could govern your vocabulary. So you could be a dictator, but it could work. But if the dictator dies, then you have a problem. You can have a moderated caucus, which means that you can have an email list and work with the people with the email list, try to get down to agreements, but it also needs a moderator. It can have some risks, mostly if the list has apathy, so they don't respond, or if the moderator is too weak or too strong, or is overloaded with too many submissions, then the tooling can help on that one. And finally, you could have a formal committee, like ISO, where people are in these groups, vote, they wait, but it's a bit too slow for publishing vocabularies. For us, in BODC, we have the governance model that each collection is allocated a content governance authority. The authorities are these ones. And one authority that has worked well is CVOX. And they have some rules that say that if you submit a new term and there is a discussion, and after the discussion there is a week of silence, then the subject is closed. If consensus cannot be reached, then there is another steering committee, the Marine XML, and the problem is taken higher, in a higher level. And once loaded, the vocabulary terms cannot be deleted, and changes to the term definitions can only broaden the meaning. These are best practices of governance, both content and technical governance. Of course, it's about have well-documented concepts. And the technical governance is about publishing quickly what you do have versioning policies, give tools to the users to interact, and have APIs for software to work. And the challenges are, as we said about the permanent URIs, are we sure that they're going to be there forever? It's about collaborative environments for vocabularies and the mappings between different vocabularies around the different domains of vocabularies around the world. It's about mappings and alignments of different ontologies, multilingualism, which will need experts from different countries in its domain. And what we were talking with Paolo and Cristiano about reasoning and inferencing using the vocabularies. Thank you.
Thank you, Alexandra. I think thank you for your presentation, because in BODC you have both important part. One is about the part of vocabularies, a lot of terms in your vocabularies, and also you presented the part of the user interface. That for me is very important aspect, especially in this moment. Okay, question.
In your vocabulary builder, you can create compound terms. What is the semantic relation you use between the compound term and the atomic terms for the measurements, the properties, and everything? Do you use oh, no predicate, okay.
They are composed of different vocabularies, but there is no predicate.
Oh, okay.
So they're not with predicate. It's semantic.
Okay. It's just to create the compound term,
Yes.
okay. But you don't capture the relation to the other vocabularies.
Please.
Yes. So if you go and check a P01 term, you will see that some of them, but not all of them, some of them will be exposed through mappings as related and broader.
In MFS, we have a similar approach to model the compound terms that are captured in databases and so on, and atomizing the terms into measurements, properties, and so on, using the related. Yes, only related. Yes. Yeah. Mm.
On the same topic, I wonder if is there any trace of this within, for example, the Oracle database, if your system is able to capture at the moment this composition process. So maybe in the future, is it possible to reconstruct how the compound term was composed?
So in order to create the tool, we had to document how each one of the vocabularies, we had to document the semantic model of the vocabularies in the database, so that when a new vocabulary which has a semantic model underneath will come, this procedure will be automatic. So L22 is a candidate vocabulary for semantic modeling, and we capture in the database how it is composed, so which are the wheels that the vocabulary is composed with, and then our software sees the information from the database and the new vocabulary is shown directly there.
Sorry, Paula, but you need to use this microphone.
Sorry. I don't know if I understood well, but maybe is it possible to go back to the origin of these compound terms, but just with label search or text processing? Is it right?
So there are different tables in Oracle that capture the whole. So we know exactly. Yes, yes, yes. So it's not just a yes. And there is a procedure that creates this description later on. So yeah, we capture the whole thing. Yes.
Nikos.
So, I would like to ask you the following. How exactly are you performing the mappings? I mean, to do it, of course, you should, since we are talking about vocabularies, do a kind of terminology matching or schema matching. Do you have a specific tool that does this, or is this a manual process? Okay, I think we can assist on this and we can talk later. I have one more question and one comment. The comment is in your slide about the different vocabularies that you are using in order to express some measurements about the species. I don't know if you can go to the slide. You had you had a sentence about a measurement of the species, and then you were presenting where you get the information for the biological entity, and maybe you shouldn't go, but you also refer to the sex of the species. Isn't this another will, let's say, isn't this an attribute of the biological entity and not the biological entity itself? Shouldn't this be represented?
I understand what you mean. I really don't know why they are aggregated. Probably that was something that should have been done that period, and that's why it was kept till now. It could be distinguished, so we could have like sex in one part and the other one. Probably it was something that needed to be done that time that the vocabulary was created.
Final question, I don't know if you can answer right now, or maybe we'll have a discussion in a coffee break or something. What do you mean by reasoning and inference using vocabularies if you don't have the properties and the relationships? Because if you also include properties and relationships, you don't have a vocabulary, you have an ontology.
So there is a requirement by people from US that are using our vocabularies, and they are mostly using instruments, instrument categories, and instrument types and models, and the parameters that they observe. And they would like to do inferencing with that. You can't do inferencing with instances, of course, but there is a way to do the all overlay, so you can keep your namespace and overlay the RDF with all, so that at the end you result in the instances being classes with subclasses and keep the namespace there. But we've tried that. It doesn't result in all DL, so I don't know if inferencing is possible. And so we are very experimental on that one.
What I'm saying is that then you have an ontology. So this is not reasoning or vocabulary, it's transforming the vocabulary into an ontology and then performing inference and reasoning using this ontology, right?
The all overlay keeps the vocabulary and the ontology in the same namespace. We don't have to change anything. So the requirement was either to create new namespaces for ontologies of the vocabulary. So transforming the vocabularies to ontologies and have a different namespace. We saw the all overlay and we said that maybe we just implement that. So we are under experiment still to see what we are gonna do with that.
Okay, thank you again, Alexandra. I don't know if we have a question or comments from remotely. Yeah, Alexandra, thank you. But okay, I have to go to another presentation, but before, I think with the presentation about Alexandra and also the presentation before to Barbara, we have a lot of things to discuss in this afternoon. One is exactly the same that Nikos mentioned before. I think the title was vocabularies versus ontology, and we need to discuss about that because also tomorrow Eva
I don't think that the matter is vocabulary versus ontology, but how do you combine these two? This is the right part.
yeah, to combine the vocabularies and ontology, but tomorrow probably we have a lot of time to discuss about that during the speech and the work. Yeah, that's the to Nicola Fiore, and I think another important point is mapping, because we have a lot of example of vocabularies, and we probably we have a lot of terms in common, and we need to understand how to combine these different vocabularies. Nick? And okay, I have and the last point, the last important point I think is Barbara mentioned before, and also Alexandra, the vocabularies governance, because it's very important to understand how to perform the creation of terms, the creation of term and another type of workflow inside to the vocabularies. Okay, I stop my comments and Nick, please, it's your time. Nick Bertrand, and about developing the multilingual aspect of MTES, again Europe Thesaurus and so on. Please.
Thank you, Alessandro. Okay, my presentation will be a bit short because Barbara introduced MFS to a large extent, so I will not dwell further into those topics. This is very much to introduce some concepts to automating some of the translation work that needs to take place to improve the multilinguality of MFS. There are already some concepts in MFS that have different translations, but that's very much the beginning. I will briefly go over what MFS is about, how different languages are supported because of the standard that we use, and how we might improve the multilingual support in MFS. So MFS is a scarce thesaurus, just like the vocabularies in the BODC, and it largely covers the environmental sciences domain, but specifically used for ecosystem and monitoring. It's aimed at scientists to annotate data, metadata, and it covers from the parameters observed, monitored in the environment, properties, can catalog instruments and so on. It uses relations within it that come from the SCORS standards. So it structures the concepts with broader, narrower exact matches and alternative names for the different concepts. You can access it at that public address. As Barbara already mentioned, it was built by integrating existing vocabularies and extending those resources to fulfill some requirements from different research projects. GMET, for example, is featured within MFS. It has concepts from AgroVoc, EuroVoc, UNIS habitats, and also vocabularies from the USLTR community. It has recently been restructured, so it maps to ONN concepts. For example, measurements, properties, and so on. If you access the top level concept of MTES, it's fairly easy to filter the concept according to what you're looking for. It features composite compound terms and also atomic terms. All the compound terms are located within MTES, within the measure concept, and the atomic terms are elsewhere within the hierarchy. It has a fairly mature governance model with a group of editors, contributors, and strong versioning of the thesaurus. The support for multiple languages inherent to the SCOS standard. So, for example, if you have a concept of animals, you can code that as animal with just a single line within the document. And similarly, you can translate alternative labels for a concept, for example, creature for animals and so on. MFES has about 3,000 terms currently, and we are looking at translating all these concepts in many different languages. It would be quite a task, even with only 3,000 terms, to translate these, not including the definitions. So I'm looking at taking MFES and linking that to existing multilingual resources. For example, DPpedia, GMET has a very good translation, and looking to use the Silk framework, which integrate different Sparkle endpoints. And then the alpha population to suggest translations for each individual terms. For example, concerto in Italian. So individual languages would have to establish groups for the language. And these people will have knowledge of the domain. And the language will allow us to enhance tests itself. So that's only for the multilingual aspects. From the other presentation, these technologies linking Thesauri can enhance the value of everybody's system. For example, establish links between vocabularies and using approach with other resources in the same way to establish the reach across the different. This establish a language group. If you're willing to contribute to the expertise, please contact help. Okay, thank you.
Thank you, Nick. And question or comments? Alexander.
Hi, Nick. Sorry, Barbara, can you tell Anna to mute? because I don't understand anything.
Barbara, sorry, just a moment. I have a question from Alexander before.
So I suppose that when using the Silk framework to suggest the mappings, is there then someone that will check through the mappings and see, yeah,
So the suggested mappings will be presented to the expert group for the language to validate the suggestions. Yes.
Barbara, you have a question?
No, I am happy because Anna has muted her micro, also I can understand and follow. That was my question. Also, to say that loudly, but she did it already. Thank you, Anna.
No, Barbara, can you repeat because or write your question or comments?
I have no question and comment. Anna has unmuted her micro and is happy to follow your discussion. That's all.
I can understand your right. We need to write. Okay, everything is fine for Barbara. Thank you. Yeah, thank you, Nick. I think. Oh, sorry.
I'm not an expertise in thesauri or vocabulary, or I start working about that with Ilaria, and we develop a thesaurus on phytoplankton traits. I have maybe it's not is a curiosity and not a question. I don't know. Why we have to use we have to translate in different language? I mean, I understand that we are a scientist. We have to use English in order to have a common language and to standardize our language. Why we have to do this? Translate or
Even though English is the main scientific language, many metadata records, for example, are captured in different languages. So if you want to provide a facility for discovery of these data sets that are in a different language, using such multilingual thesaurus provide the glue between a non-translated metadata record, for example, and a discovery search engine for discovering particular data sets. That's one use case.
I think that the best effort is to translate for our own language in English in order that everybody can use maybe
I think it goes both ways. For example, you may have a discovery interface that can capture different languages. So if an Italian user uses the Italian term, it can discover English data records or Serbian, or the thesauri itself provides that link between the different languages without having to translate the whole document. The user can discover data sets that are not captured in the target language.
Comment? Do you have a comment about that?
Also consider the mapping process, which is an important task in the development of heterogeneous thesauri and the interlinking of them. it is extremely useful to have multilingual representations for terms, because for instance my thesaurus can be in Italian. Your thesaurus may be original in English, but if your thesaurus also have the Italian translation of the term, or mine has an English one for it, then we can easily map the two. Consider that currently syntactic matching is the best way to find these correspondences between terms, because semantic mapping is still a long way to come.
Thank you, Cristiano.
Just to add something on this, we should also consider what we are trying to do in LiveGods. So in LiveGods Italy, I guess it's the same with LiveGods Greece. We have scientists that don't know English. So there are some Greek scientists or Italian scientists that are not used in speaking English. So they want to formulate their queries in Greek or in Italian. Or for example, if you consider LiveGods Sweden, they don't have English services at all. They are just using the Swedish language. Apart from this, regarding Silk, were you happy of using Silk? I mean in terms of performance, because I don't have a very good experience with it.
Based on the initial testing, the size of MTHES is not an issue. I may encounter a different problem if I'm integrating with the PDF. Yes.
Okay, thank you, Nick. We have a time for, I think, okay. We can have two different options now, to have a lunch break or lunch time, and to continue and to start again in the afternoon at 2:30, or we can have a last presentation from Ilaria, and we can continue to, depends how many slides do you have. 15, okay. 50, okay. Fast. Okay, I think we have a time for last presentation, and after we can manage to have a break, lunch break.
No, it's better. So, I will talk you about Thesauri produced by LifeWatch Italy community, and I will focus on methodology used to provide them, and I will present you some use cases of this Thesauri in managing of data and metadata. So, as you know, Thesaurus is a hierarchical controlled vocabulary designed to define a list of key terms and to capture how they are associated with each other. The domain of interest in LifeWatch Italy community is biodiversity and ecosystems. This domain is characterized by increasingly large volume of data collected across different domain. Sorry. And for example, for environmental, for taxonomy, for functional biodiversity, from ecology, from genomics. So the problem is that we have a lot of data, but these data are highly heterogeneous. for format, for content, and for semantics. So the absence of standard terminological impedes data discovery, data integration, and data reusability. So we need to harmonize and standardize this data in order to share information and support and facilitate the research in this field. LifeWatch working group decide to use Thesauri. We have already produced different Thesauri, some in specific subdomain of biodiversity, such as functional traits of aquatic organism, in particular for phytoplankton, macrozoobenthos, fish, and zooplankton. We produce about 250 functional traits, and they are mostly morphological traits. We have also produced Thesauri on alien species with about 300 terms, and one genomic and barcoding thesaurus with about 100 terms. So all these thesauries are well-defined description agreed by expert community, and they are in SCOS, so we can consider a stable reference resource. They are free and open. We can try this Thesauri in catalog of services in LifeWatch data portal. And they are accessible through web services, SparkWell Endpoint and API. So the first step before to start the construction of Thesauri was to select an editing tool. The Italy working group decided to use Tematres, which is a web-based tool, open source. And the main reason for this choice are flexible and user-friendly interface, sophisticated search capability, and the possibility to export thesaurus in different standards, such as COS. So before the construction, we had done a sort of configuration, customization of Tematres tool in order to define some different node type, such as preferred label, alternative label, definition, bibliographic note, scope note, but also for consider some relationship as broader, narrower, and related. And finally, for decide some kind of links as exact match, close match, and so on. So the first step of thesaurus development was the selection of terms. So LifeWatch community selected terms by gathering them from existing database or relevant literature, or by examining pre-existing thesauri and ontology in order to not repeat the same terms and definition. After the first phase, we have the edition phase. During this phase, editor group selects a list of terms and different structural elements, such as preferred label, alternative label, that could be, for example, in this case, abbreviation that is useful in this knowledge domain, domain of knowledge. We provide also a definition and preferred unit and relationship with a daughter and mother terms. So after this phase, we have a validation phase. where all the list of terms and definition and structural elements are provided by time at rest interface at another group of experts in the domain. In this case, expert can approve or reject terms and all elements by a private notes course. So after validation phase, editor group can decide to approve or not the annotation of a group of experts, and finally can publish the final version of Thesaurus. We can see Thesaurus by different search options. We can use a hierarchy tree. We can use alphabetic letter. Or we can use a search engine with out completed. And finally, we can use advanced search, where it's possible to search term or not type, or the date of creation, and so on. So now I will present some use cases of the LifeWatch Thesauri in LifeWatch data portal. We use these thesauries, for example, for data annotation. So each field of data portal of LifeWatch is integrated with information which are take from Thesauri. So we have each parameters present information. For example, the name of parameters, the description, the unit of measure, the name of thesaurus, and other information. This is important because in this way we provide a common naming, a characterization of parameters. And then this is a fundamental topic for make data interoperable. So we can also use, yes, okay. All this information is possible to see by data contributors for LifeWatch in the LifeWatch standard guide. The LifeWatch standard guide is constituted from all field with and for all field we have information that are all in Thesauri, LifeWatch Thesauri, or related Thesauri such as MTES or BODC, or for example about the data on primary biodiversity, we use Darwin Code standard. So we use also LifeWatch Thesauri for populating a given field in metadata model. In the case of LifeWatch, the metadata model is based on Drupal ecological information system used for LTR network. And we can use, for example, Thesauri for give content at some metadata element, such as keywords. We can use LifeWatch Thesauris, but not only, also MTES, Lustre, Heart. So future step. We have already started the improvement extension of existing Thesauri, particularly functional Thesauri on functional traits. The idea is to implement and publish Thesauri on other specific domain needed for LifeWatch, but not only, for research community in general. Integrate our Thesauri with MTES, and we have already started a sort of cooperation for do it. But also the idea is with BODC and other SCOS vocabulary. I think this is a fundamental topic that we have to discuss tomorrow during the roundtable of Paolo, because I think at European level it's very important to decide standard vocabularies, and all together we have to decide what is better for the ecology research community. Because we have a lot of thesauri. Some of these thesauries have same term but with different description. So we can agree for definition for the label, and we can start something to make really data interoperable. Finally, Thesauri will be used as building blocks for the life watch ontology. I don't know, I have the same question of Nikos, but I think also this is a topic for a future proposal. And so we can discuss about this with Nicola tomorrow. So thank you.
Thank you, Ilaria. Question, comments? Okay, we have a lot of time to discuss about the question and the future developments in the roundtable of tomorrow, and also I think in this afternoon after all the presentation. Okay, thank you so much. Okay.
Not a question, but a comment, because I think that LifeWatch as probably an infrastructure in the near future could also offer those characteristics necessary, for example, to grant persistence to vocabularies, endpoints, and jointly with Greece and the other LifeWatch partners. I think that an initiative with respect to vocabulary management, maybe ontologies, but in a broad perspective, I think 20 annual perspective of an ERIC, it could be really an opportunity for us, but also I imagine for MTES, for a collaboration with the ODC and NERC. So I think that could be an important moment to discuss these things together, to have some agreement. I think that it is an opportunity. So thank you, Ilaria.
Thank you, Paolo. I agree about that, and also I remember that also LTR is in the way for a ERIC process, and so probably is a good opportunity. Again an opportunity to discuss about this aspect in this moment.
My only comment is about what you've been saying about selecting the reference thesauri to be used. I don't think that there can be a good choice that is good for everybody, because for instance at European level they've been building the Gemeta thesaurus a long time ago, but most of the thesauri we are discussing in these days have been created because Gemet was not deemed as specific enough. So I think that the challenge is putting together mapping independent thesauri to extend, for instance, Gemet for those terms that are not specific enough.
Again, there is a lot of keywords emerging during the presentation, and mapping is another keywords, and governance, O&M, and also on the part of ontology, and we have a lot of things to discuss and to things. Okay, it's the lunch time, and comment from remotely. Anna, Barbara, you hear me again?
I could follow good last hour. So thank you very much. I'm very happy also to discuss tomorrow. But at the moment, I have no question.
Thank you, Barbara. I think we return in the real room and at 2:30, and so we can contact you again. Anna?
Yes, of course. Thank you very much for your
Okay.
invitation.
Thank you, Anna. Okay, we close the room, and so we return after the lunch.